Today we'll be talking about the law of sines and the law of cosines, which can both be used to find the angles and sides of a triangle. Here we have another example. Our triangle PMN has sides of 6, 8, and 11, and as we only have sides, to solve the triangle we'll need to find all three of the missing angles. And since we have three sides, or side, 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 what we can use is the law of cosines, which is a squared equals b squared plus c squared minus 2bc times cosine of a. And so since we're not using a, b, and c, but we're using p, m, and n, we'll change it to p squared equals n squared plus m squared minus 2nm times the cosine of p. And we'll be solving for angle p first. Plugging in our side lengths, we'll change it to 11 squared equals 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of p. Multiply out our exponents and we'll have 121 equals 36 plus 64 minus 96 times the cosine of p. We'll subtract 64 and 36 by both sides and we'll end up with 21 equals negative 96 times the cosine of p. Now we'll divide both sides by negative 96 to get negative 7 divided by 32 equal to cosine of p. We'll take the inverse cosine of both sides, giving us p is equal to the inverse cosine of 7 over 32. If we put that in our calculator, we get p is equal to 77.36 degrees, and we'll have that on our triangle now. Next, we'll use the law of sines, as we now have an angle and its opposite side and another side. And so we'll use p11 and we'll start with m. And so we'll take sine of p over p equal to the sine of angle m over side length m. Plugging in our numbers, we get the sine of 77.36 over 11 is equal to sine of m over 8. We multiply both sides by 8 to get 8 times the sine of 77.36 over 11 equal to the sine of m. Taking the inverse sine of both sides, we get m is equal to the inverse sine of 8 times sine of 77.6 over 11. We put that in our calculator, we'll get m is equal to 45.21 degrees. We'll put that on our triangle too. Now, since all triangles' angles add up to 180, we don't need to use the law of sines or the law of cosines to find our third angle. Instead, we'll subtract both of our other angles from 180. So do 180 minus 77.6 minus 77.36 minus 45.21, which is equal to 57.43 degrees. So that'll be angle n. Now we have all our angles and our sides, and we've solved the triangle using the law of cosines and the law of sines.
When you have a triangle in which two of the sides are the same, you know that both of the bottom angles are the same also. So by the time that you find the upper angle, it's easy to find both of the bottom angles, because you just have to subtract the upper angle by 180 and then divide by 2. So then you have the angle value for both of them, because and that help you because you don't have to actually do any math formulas, remember any formulas to solve this problem. It's just logic, so that helps a lot. And if you know the bottom angle and you find one of the angles of this triangle here, the first triangle, you basically know the other angle. So by the time you find one of the sides of the big sides with a little cross on it, you know that the other side with the cross is the same size. That's why it has one cross. The cross is gonna tell you if it's the same or not. So if it has one cross, it means that it's the same of the one with one cross also. But if this one, if one of the cross, one of the side was one cross and the other one was two cross, it means that it's different. So the sides are not equal. But that's not the case right now. And in the second triangle right here, you have a triangle in which you know that all the angles are 60. Okay, when you have all angles 60 degrees, all the sides are also the same. So this is a triangle that you don't actually have to make any calculus. You just have to find one of the angles, and by the time you find one of the angles, you just have to put the answer because you have all the angles already. So you basically don't need anything to solve this two problems. So by the time you're gonna solve any problem in which you have to analyze a triangle, you always have to remember that if two of the angles are 60, you know that the third is 60 and all the sides are the same. And if two sides are the same, you know that both of the bottom angles are also the same. You know by looking at these triangles, two of its angle and one side length. At this moment, we already know that the best formula to use in this case is the law of sines, which is the formula right here. The side, which is the side A over sine A, equals side C over sine C of angle C. Plugging in the values, we have this right here. Because side A is 8, angle A is 30, and angle C is 55. Now we're gonna cross multiply them, and what we get it's sine of angle of 30 degrees times side C equals 8 times sine of 55. By solving this, we have 8 sine of 55 over sine of 30, which when we plug in our calculator, we get more or less 13.1.
Alright, so there we're giving our triangle ABC and we're giving side angle. So first off, we want to find the value of angle C, which you can do by the law of sines. Alright, so I just plugged in the numbers for our side and a sine equals 20 divided by sine C. Then we want to isolate the sine C, which I did right there. It's going to make the equation look like this. And I get sine C equals 0.342. Then I need to take the inverse sine of both sides. Alright, I did that, and it's going to give us our C equals 20. Then we're just going to find our value of angle B by dividing 180 degrees by minus 2010 minus 20 gives us 50. Then all we need to do is find our value for side B, which we're going to also do by the law of sines. So I just plugged in the numbers, and we want to isolate this equation for B, which I do by multiplying with sine 50, which is going to make the equation look like this, and it's going to give us B equals 44.84, and now we got all the measurements for our